In this video, I want to show you how to calculate the heat of the solution, and sometimes it's called the enthalpy of solution. So here's a definition. So for the enthalpy of solution or heat of solution, it's the amount of energy associated with an ionic compound dissolving in water. So when that ionic compound dissolves, it dissociates into the ions that make it up, and there's a specific amount of energy that is either released or absorbed during the dissociation process. So the units are normally kilojoules per mole. And a little bit later on in the unit, you can actually calculate that value by using a table that has heats of formation, but we're going to start out a little bit more basic than that. So part of the idea behind some of the lessons is that you can have hot packs and that you can have cold packs. So one example of a hot pack would be if you had calcium chloride and it was a solid, and let's pretend you had it in a hot pack and there's a membrane separating it from water. And when you need the hot pack, you basically break the membrane, the calcium chloride dissociates into ions, and then the water becomes hot and you can use it as a hot pack. So one way to write this particular reaction would be calcium chloride as a solid gives you calcium ions in solution and chloride ions in solution. Now, since this particular reaction gives off heat, we say that it's heat of solution, and it should be negative if it's giving off heat. And the particular value for calcium chloride's heat of solution is negative 82.8 kilojoules per mole. So the reaction is exothermic, heat is leaving the system, but the water itself is heating up. Sometimes this could be written as putting the actual heat on the product side. So you can look at it as the 82.8 kilojoules is written as a product because it's producing or giving off energy. So this is one example of an ionic compound going into solution and giving off heat. A different example would be if we had ammonium nitrate. So if I have ammonium nitrate and it's a solid, and I also have it in a cold pack, and you basically break the membrane and then it turns into a cold pack. So if you were to have ammonium nitrate, it would dissociate into its ions and that would be aqueous. Instead of the heat coming off, this reaction actually absorbs heat from its surroundings. And the heat of solution for this reaction is positive 25.7 kilojoules per mole. So sometimes you'll see it written over here. You might have 25.7 kilojoules plus ammonium nitrate solid yields ammonium ions plus nitrate ions. So in this case, it's endothermic. So the actual dissolving of ammonium nitrate requires heat, and it takes it from the surroundings, so then the temperature of that water drops down. So that's the difference between a hot pack and a cold pack.